Dilution. This is the subtopic I am going to be discussing in this demonstration before I start calculating some questions on dilution. The purpose of this study is just to expose us to what happens when we are diluting the substance or the chemical substance. So by definition, we define dilution as the process of reducing the concentration of the chemical substance by adding the ionized water so that we can form a desired concentration of the reagent or chemical substance. So dilution is very important because sometimes we may need just to have a very low concentration of the substance. That's the reason why it is very important as scientists to know how to calculate the concentration of the substance. And when we are diluting, we should know the formula to use when we are reducing the concentration of the chemical substance to the desired concentration. This topic is very practical. In industries, even in homes, many of the times we buy concentrated juices, but we don't take those juices just like that. We happen to dilute them so that we can suit our demand or we can suit the possible concentration that the body needs. Otherwise, too much concentrated solution will affect our body cells. We understand that. So we need to be taking the juice which is to the concentration according to our desire. Now, when we are not doing a practical, we'll be asked to calculate the concentration when we have diluted the solution, or we can be questioned to find the number or the volume of water that must be added so that we can form a desired concentration. If you want to make 2 molar solution from the stock concentration, for example, if the concentration is 12, the concentration is 12 molar. Now, from this 12, you just want to make, this is the stock concentration of the container. The concentration of the solution is 12. And then you just want to make maybe 2 molar solution. How are you going to do it? Number one, you'll be required to know the volume of the chemical substance that we are supposed to get from this 12 molar. Okay? You need to know the volume you are supposed to get from the stock concentrated solution. And then you are going to dilute it to the desired volume. For example, you want to dissolve this reagent maybe in 1 liter. Since you want to make 2 molar, okay, you want to make 2 molar, and then you want to dissolve that 2 molar in 1 liter. What volume are you going to get from this container containing this reagent? So the formula you are going to use is here. We use C1 V1 equals C2 V2, where this C1 indicates the initial concentration, and this volume is initial volume. This is the final volume, and this is the should I say final concentration and then final volume. This is the formula. So here you are going to say, okay, the initial concentration that you have is actually 12. And the volume you want to get it from this 12, you don't know. Okay? So you are going to say 12 as the concentration, but the volume you want to get it from this, you don't know. So it will remain V1 here equals the concentration you want to make here is 2 molar, and then the final volume you are going to get when you dissolve this 2 molar, you are saying you want to make 1 liter, so you say times 1 liter. One liter. So you are going to divide both sides by 12 molar over 12 molar. Molar and molar will go 12 into 2, because 2 times 1 it will be 2. So 12 into 2, you are going to find that the volume we are going to get from the container will be actually nothing else but 2 divided by 12, which will be 0.2. So the volume we are going to get from the container will be just 0.2. I am just demonstrating the concept on how we do it. Now, in my demonstration, I am interested in exposing you to what happens when we are performing this in the laboratory. Intelligent people, look at this. I am having the solute. The solute is the substance that is dissolved in a solution or solvent. And the solution is actually the substance that is going to be formed when we dissolve the particular amount of the solvent in the when we dissolve the particular amount of solute in the given solvent, we are going to form the solution. And I am going to have the solution concentration there, which will be indicating the concentration of the substance when I add the solute to the solvent. Here I am using the solvent water. And the reading when I'm just having water is 0.00 molar, which means water has no concentration since it has no ions. So this is what I'll be doing. You take note, you pay attention to the amount of moles I'm going to be adding. So in the first place, I am going to add the solute to 0.5 liters, which is 1/2. That is 0.5 liters. We'll see the initial concentration we are going to get. So this is what I'm trying to do. Now, in the solute, the amount of water I'm having there is 0.2 liters, as you can see it here. I want to be specific. Yes, 0.2 liters. Now I'll add some more amount. As you can see there, I have added 0.5, or maybe I do it like this. Yes, so that I can have 0.5. That 8 can be rounded off like that. So that is same as 0.5 liters. Okay, so this is my initial volume of water. Okay, and then to this initial volume of water I am going to add 0.63 moles, and the concentration becomes 0.5. This is going to be initial concentration, and this is the volume, initial volume. So volume 1, concentration 1. Okay, now what will be the concentration when I add 1 liter? So meaning this 1 liter here will become the volume 2. What will be the concentration? You can be questioned like that. What will be the concentration when 1 liter is added? Meaning you are adding more water. So let me add more water like that. So it will be, you can see that the concentration is reducing. The concentration is actually reducing. So this is what we imply when we are explaining dilution. So what we reduce is the concentration, and the number of moles remains the same. When I reduce the volume, the number of moles are not changing. The number of moles are just remaining the same. But the concentration this side is increasing when I'm reducing the volume of the solvent. That is also very important, my dear learners, for you to understand. You need to understand that the number of moles does not change. What changes is the concentration. But when we are increasing the number of moles, we are adding more solute, we are going to be increasing the concentration of the substance. You can use anything. If you want, you can try to use potassium dichromate as the substance you are trying to make or to dilute. The results will be okay. Thank you so much. I understand when I'll be doing calculations in the theory, you are not going to be facing challenges. So in the next hour or time, I am going to be calculating some theoretical questions so that you can be able to apply the concept I have just explained. Are you still there? Okay, so let us do some calculations on dilution now. First question. 0.25 decimeter cubic of concentrated sulfuric acid of concentration 18.0 molar is diluted to give a solution of 2 molar. Meaning the initial concentration is 18. Now, when we dilute, the solution is being diluted to 2 molar. What is the new volume of the diluted solution? This is what I was saying in my demonstration. So it's same as they are saying we have the solution like this, and the volume of this solution is 0.25 25 decimeter cubic. And the concentration is 18 molar. Now, we are diluting, we are adding more water so that we can have the concentration which is going to be 2 molar. Now, what will be the volume here? That's a question, meaning the volume is not known. So we are going to have concentration 1, volume 1, concentration 2, volume 2. This is the thinking, my dear learners. This is what I was demonstrating in my video on the practical side. Okay, let us solve this simple question. I know you can even pause the video, you will still answer it. Let's go to the whiteboard. We clean the board. Thank you. And then now we can collect the data. We have the volume 1. Remember, we are dealing with sulfuric acid. We are trying to dilute sulfuric acid here. Volume 1 of sulfuric acid is 0.25 decimeter cubic. And the concentration 1 of this acid is 18.0 molar. Concentration 2 of volume 2 is what we are looking for. We have X. And then concentration, when we add this volume, they have given us that it will be 2 molar. What will be the volume? This is very simple, my dear learners. This is what we do. We are going to use this formula. Concentration 1 times volume 1 equals concentration 2 times volume 2. Why are we equating these two substances? Remember, CV is the formula we use to calculate the number of moles under concentration. Now that the number of moles does not change, when we say C1V1, the number of moles will remain the same even if when we say C2V2. That's the reason why, since number of moles equals number of moles, we are replacing where we have number of moles with this, and where we have the number of moles with that. This is what we are doing. Why? Because the number of moles does not change, as you observed when I was demonstrating. Okay, interesting. Let us put the values. Concentration, the initial concentration is 18 molar. The volume 1 is 0.25 decimeter cubic equals, then concentration 2 is 2 molar. V2 is not known. So we are going to say over 2 molar over 2 molar. This 2 molar and this 2 molar will go. This molar and this molar will go. When you use your calculator, you'll find that the concentration value for V2 will be equal to 2.25 decimeter cubic. This is the way to go. This is very, very simple. We look at the next question. Question 2. 50 centimeter cubic of 1.5 molar potassium hydroxide solution is diluted to 200. Calculate the new concentration of the solution. Here your thinking should be like this, my dear learners. We are having 50 centimeter cubic of potassium there, potassium hydroxide. And the volume is 50. The concentration is 1.5 molar. And then we are adding more water up to 200. What will be the final concentration? Concentration 2, we don't know. So this is the thinking. Okay. We go to the whiteboard. Again, we are going to say C1 V1 equals C2 V2. Okay. Concentration is 1.5. molar, and the volume is 50 centimeter cubic. No need of converting units, my dear learners. And the final volume will be 200 centimeter cubic. The concentration 2 is not known. This is what we are looking for. So over 200 centimeter cubic over 200 centimeter cubic. This and this will go. So our concentration 2, when 200 is added, this will go. When you calculate very well, I think your final answer should be 0.38 molar. That's very good. Just use the calculator very well, because 1.5 times 50 equals 75. 75 divide 200. Yeah. So take note of the value. We can go to the third question, or maybe the third question I can leave it for you to answer it, because I understand these things are not difficult. What volume of water must be added to 30 centimeter cubic of 2 molar nitric acid solution to produce 0.2 molar solution? So I'm going to use the same space here. So we have what volume of water must be added to. So the initial volume is here, initial volume, volume 1, and the concentration is 2. So this is concentration there. Then the final concentration when we add that volume will be concentration 2. Volume 2 is what we are looking for. This we don't have. So we are going to say, we need to analyze this question very well. What volume of water must be added to 30 centimeter cubic of 2 molar nitric acid solution? What volume of water? So this is very simple. Same as we have this volume. This volume is 30 centimeter cubic. This is the volume of the nitric acid and its concentration is 2 molar. Now we want to dilute this 2 molar to 0.2. What will be the volume that must be added? Because when we are adding that volume, I think the volume will be increasing. Okay? So you need to be very, very, very careful. Very, very, very careful. So let us do the calculation now. We start. C1 V1 equals C2 V2. Concentration number 1 is 2 molar times the volume of that 2 molar is 30 centimeter cubic. The concentration is of the final is 0.2 molar. The volume that must be added as for us to have 2 molar is not known. So we are saying V2 is not known over 0.2 molar over 0.2 molar. So what are we going to do? What volume must we add? So the volume, when you use your calculator very well, V2 equals, you say 60 divide 0.2, 60 divide 0.2, the answer should be 300. 300 centimeter cubic. This is the answer. Thank you so much for understanding. This is just very simple. I know I deal with intelligent learners. I am not even worried you are going to pull through. Thank you so much and take care of yourselves.